like to express our special gratitude to our dearly loved lecturer, Madam Nur Hidayah, who gave us this great opportunity to do this project within the time given. We sincerely thank our lecturer of Calculus 1, Madam Nur Hidayah, for all the guidance and willingness to help us complete this assignment. This assignment is impossible to complete without Madam Hidayah and the effort and cooperation of our group members. What is differentiation? Differentiation is a method of finding the derivative or a rate of change of a function. It is defined as dy over dx equals to f prime x equals to y prime. To solve differentiation problems, we can apply three different techniques, which are 1. Derivative of sum and difference, 2. Derivative of a product function, which is known as product rule, and 3. Derivative of rational function, which is known as quotient rule. There are 5 applications of differentiation. The first one is related rates. The second one is the first analysis of function, which is increase, decrease, and concavity. The third one is the second analysis of function, which is relative extrema, the first and second derivative test. The fourth one is applied maximum and minimum problems. And the last one is Rolle's theorem and mean value theorem.
Okay, let's go forward for related rates. What is related rates? Related rates is a calculus problem that involves finding the rate at which one quantity change in relation to the rate of change of another related quantity. The rate of change is usually with respect to time. It is known as the gradient or slope when change occur during the comparison of two quantities. This is an example for related rate. When a balloon is being filled with air, both the radius and the volume of the balloon will increase. This is a solving step in related rates. Firstly, read the problem carefully and draw a diagram if possible. Second, label all the quantities mentioned and identify the rate of change in the problem. Third, find an equation that relates the quantity whose rate of change is to be found to the quantities whose rate of change is known. Fourth, use the chain rule or implicit to difference both sides of the equation. And lastly, solve the derivative that will give the unknown rate of change.
Next is the problem statement. A conical water tank has a radius of 3 cm at the top and 15 cm high as shown below. Water flows into the tank at a rate of 6 cm³ per second. The hint is given in this problem statement, which is the volume of cone is equal to 1/3 pi r square h. So the first question is, show that the volume of water is given by V is equal to pi h³ over 75. And the second question is, how fast is the height changing at an instant when the height of the water is 5 cm. So next, we will moving on to the problem solution 1. So the first question is, show that the volume of water is given by V is equal to pi h³ over 75. So, based on this question, we need to modify the original formula by replacing the elements present in the formula with the information provided in the question. Given that the radius is equal to 3 cm and the height is equal to 15 cm, in this case, we need to replace r with h because we need to express V in terms of h. But first, based on the provided information of r and h, we need to create a fractional equation, which will be r over h is equal to 3 over 15. Next, we will obtain the answer that r is equal to 1 over 5h. The next step is, by taking the previously obtained value of r, substitute it into the original formula of the cone. Next is problem solution 2. The next question is, how fast is the height changing at an instant when the height of the water is 5 cm? Given that h is equal to 5 cm, v is equal to pi h cubed over 75 and dv over dt is equal to 6 cm cubed per second. So, we need to find dh over dt, which will be dh over dv times with dv over dt. Firstly, we need to find the derivative of dv over dh, which is equal to pi h squared over 25. Then, we need to invert the answer to be dh over dv, which is equal to 25 over pi h squared. Secondly, substitute the value of dh over dv and dv over dt into the formula. Then, we will get the final answer of 6 over pi centimeter per second.
From the problem solution, we can conclude that the application of differentiation for calculating the volume of the water tank proves to be a powerful and practical tool. By applying differentiation method into this problem, we can derive a precise and efficient formula for determining the volume of complex geometric shapes such as cylindrical or conical water tanks. Moreover, the application of differentiation plays a crucial role in various fields and beneficial in dealing with business or other difficulties which need calculation in our life.